All right, so in this section, we're going to want to talk a little bit more and do some example problems from Chapter 6 materials. And ultimately, this is going to cover our concepts of the mole. So remember, we said a mole is our counting device. So we said that 1 mole is equal to 6.02 times 10 to the 23rd. And in our case, we're going to be talking about things like atoms, maybe molecules, and ions. So really, a mole could be anything that you wanted to talk about. But when we say we have 1 mole of a substance, that means that we have 6.02 times 10 to the 23rd of that substance. And we also know that when we're talking about chemical formulas, that a mole is also equivalent to the molar mass. So it also equals the molar mass in grams. And that's great because now we have a way that we can actually convert between the mole and grams, which is something that we can weigh on a scale. So we said in class on Tuesday, that because of this relationship, we have one of 3 different conversion factors that we can end up writing. So the first conversion factor is going to allow you to go between mass and the mole. So when you see equations that are either going from mass to number of moles or from moles to number of grams, you would know that you're going to use this conversion factor here, that the molar mass in grams is equivalent to 1 mole, or you can say the molar mass in grams over 1 mole. And you can also flip-flop this depending on how you need it. You could have 1 mole over the molar mass. So our second way of looking at this is to compare 1 mole with the number of atoms, molecules, or ions. So we also can say that there are 6.02 times 10 to the 23rd molecules per 1 mole. Or we can have, again, this could be on top as well. So we could say we have 1 mole over 6.02 times 10 to the 23rd molecules. It's just going to depend on what we want to calculate. So this is the second conversion factor that we can have. And our third is going to be this relationship here. So if our molar mass in grams equals 1 mole, and 6.02 times 10 to the 23rd atoms equals 1 mole, then we can say our molar mass is going to equal 6.02 times 10 to the 23rd. So for this conversion factor, the number 2 conversion factor, this would be looking at number of molecules and going to the mole. So anytime we have problems that are asking us about number of molecules or number of atoms, we're going to want to use Avogadro's number to figure out those equations or those problems. So in our third situation, our third cofactor is going to allow us to go between the mass in grams. So it's going to allow us to go between mass in grams and molecules, or number of molecules. And so we can write this conversion factor over the molar mass in grams. So we've got 6.02 times 10 to the 23rd molecules over the molar mass in grams. And again, we can use this conversion factor in either direction as well. So we can put molar mass on top in grams and the number of molecules on the bottom. Again, it's just going to depend on what we want to calculate. So we'll keep coming back to this setup when we want to calculate different equations. So in the next section, we're going to do some example problems using these different conversion factors.